Greetings, science family. Today we are going to be looking into ionic compounds. What are they? How do we name them? How do we write their formulas? Just get a little bit of a better idea of what an ionic bond is and just a little better idea of how the world works. So let's begin. To start with an ionic bond, you need a metal and a nonmetal. And let's get into why that is. So in order for an ionic bond to happen, you need a cation and an anion to attract to each other. Remember, a cation is a positive charge and an anion is a negative charge. And we know that opposite charges attract. In order to do this, in order to make this happen, electrons have to be donated, meaning that electrons have to be transferred from a metal to a nonmetal. And when you do that, when you transfer electrons and metals lose an electron and nonmetals gain an electron, the metal becomes a cation, positively charged, and the nonmetal becomes an anion, which is negatively charged. And that's what brings them together. So by donating electrons, we get a positive and negative charge for the metal and the nonmetal. And when they come together, they are much more stable because they become electrically neutral, meaning they no longer have a charge. And remember, all atoms are just trying to be more stable, which means lower energy. So in the end, we have a positive and negative charge attracting to each other, coming together in order to cancel out to make a zero charge. So that's what an ionic bond is. And of course, ionic bonds make ionic compounds. If we look at the properties of ionic compounds, if you think of something, the most simple ionic compound that we often think of and relate into our everyday life is table salt. All right, if you think about it, if you ever tried to melt table salt or even cooked with it, it doesn't melt. So table salt has a really high melting point. So do most ionic compounds. Also, ionic compounds, just like salt, tend to be brittle. So think of that crumbly feeling if you smushed it between your fingers. Also, majority of ionic compounds dissolve in water. And when they dissolve in water, they become what are called electrolytes. And electrolytes mean that when they're dissolved in water, ionic compounds actually conduct electricity. So when you think of electrolytes, you might think of like Gatorade, a sports drink, and that's normal. Gatorade does have electrolytes, meaning it has salts or ionic compounds, and that can replenish our body and muscles and our fluids in order to allow our muscles to work at peak performance. The thing about Gatorade is it has extra sugars, and honestly, you don't need tons of electrolytes if you're just playing a game. Now, if you have a full day tournament, and maybe you have 5 different volleyball matches, or soccer tournament, and you have 3 huge long games, or you're running a marathon, then definitely you need to replenish your electrolytes. But otherwise, if you're just having a pickup game of basketball with friends, you really don't need to load down on the sugars and electrolytes. Having water should be enough, and it cuts the calories too. Now, this picture here is good because this is what, on a microscopic level, table salt looks like, the sodium and the chlorines together. But when we put them in the water, what happens is it breaks up into its chlorine and its sodium ions, and water surrounds it. That'll be important because of this positive and negative charge in the water allow it to conduct electricity. And again, that's why ionic compounds are called electrolytes, because they conduct electricity when dissolved in water. Something else that's super important that a lot of people don't know about is that formula units are what we call the smallest piece of an ionic compound. People use molecules left and right for everything, but that is not true. For ionic compounds, the smallest piece is called a formula unit. For covalent compounds, we call those smallest pieces molecules. So keep that in mind. Formula units are ionic compounds, molecules are covalent compounds. When we start naming ionic compounds, it's very simple. We're always going to put the metal or the cation first. So the one with the positive charge is always going to go first in the name, and the anion, or often nonmetal, will go second in the name. So it'll always be positive or cation first and anion second in the name, which usually is going to be, again, the metal first and the nonmetal second. So now that we talked about the cations first and anions seconds, let's focus a little bit more on naming the cations. All right, so for the cations, here's the deal. If a cation, that metal typically has just a charge, one charge. So like sodium ions always are a sodium plus one charge because it's an alkali metal. since that is the case, when we name it in a formula for an ionic compound, we're just going to call it sodium. That's it. There's no special name for it. There's also no prefixes like mono, di, tri. There's none of that. Because these ionic compounds come together by charge, you will simply use their names because we'll know their charge if we look them up. But sometimes different metals can have more than one charge, and that's the transition metals. Some of the transition metals can have, depending on where the electrons move, can have different amounts of charge. So for example, iron is that example, and that's a transition metal. Iron can either have a +2 charge or a +3 charge. So if we named it in a compound, you can see how just calling it iron could be confusing. You would think, wait, does it have a +2 or a +3 charge? So we have to be more specific when we name metals that can have more than one charge. So to do that, we just use Roman numerals. It's as easy as that. So in the name, instead of just calling it iron, for iron 2+, we would call it iron parentheses 2. That's the Roman numeral 2. For iron 3+, we would call it iron parentheses Roman numeral 3 to say that, hey, this is iron, but this is the iron that has a 3+ charge. If you guys aren't familiar with Roman numerals, the only ones you'll need to know is 1, letter I, 2, II, 3, III, and 4 is IV. IV means it's 1 less than 5, and 5 is a V. So you'll get used to that if you've never done Roman numerals. But in the end, we're just going to use the cation or the metal name to start the ionic compound's name. But if it has more than one charge, don't forget you have to use a Roman numeral. Let's practice naming these guys really quick. So if calcium's 2+, if we look, calcium's an alkaline earth metal. It's not going to have more than one charge. It's not a transition. So we're just going to name that the calcium ion. That's it. We'll just call it calcium. Aluminum. Aluminum's not a transition metal, so it has only one charge. So we would just call that in the name aluminum. Okay? But now take a look at these guys. Copper. They have two different charges to them, and they're transition metals. So in the name of the compound, I couldn't just call these guys copper, because as you can see, you wouldn't know which one I was talking about. So for copper +1, in the name, I'm going to put copper Roman numeral 1 in parentheses. For copper +2, I'm going to put copper 2 Roman numeral in the name in parentheses. So that's how we distinguish between them. Lead, a transition metal that also has more than one charge. So even though Pb is lead, I couldn't just use the name lead in the compound. It wouldn't work. Why? Because I don't know which charge it would be. So since this lead is 2+, I would call it lead 2. Since this lead is 4+, I would call it lead 4, which remember 4 is IV. So just do the Roman numeral in parentheses and you're all set. For lithium, lithium is just a regular alkali metal. It's not a transition, so we don't have to worry about any of that Roman numeral stuff. We just call it lithium. Simple as that. So we started with the cations, but we always finish with the anions. So naming the anions, it's nice because anions always have the same charge. Their charges don't change. So we don't have to worry about anything with those Roman numerals. The only thing you have to do is for that element, the nonmetal, when it becomes an ion, we change it from the name of the element to ending in "ide." So we would change this fluorine to fluoride. That's it. So fluorine has a -1 charge, and instead of calling it fluorine, we call it the fluoride ion. So the IDE ending lets us know that that is an anion, a negative charge. So really quick, let's practice naming. Chlorine by itself is chlorine, so as a negative ion, we would call that chloride. Nitrogen is by itself called nitrogen, but as an anion, we would call that nitride. Bromine by itself is just bromine, but as an anion, we would call it bromide. Oxygen by itself is just oxygen, but as an anion is called oxide. So again, notice that we just have that IDE ending. That's similar to covalent compounds. We end in "ide" as well. So that's something similar. But remember, notice we didn't use any of those prefixes like mono, di, tri, any of that stuff. We do not use that when we do ionic compounds. We only use that for covalent. So we will finish up as part 1 with just that introduction, that ionic compounds are cations and anions put together. Now, there are some more sophisticated ions called polyatomics that we'll introduce next, but we'll go over that in part 2 of ionic compounds, and then we'll start practicing naming and writing formulas together. But for now, that's all the information we need, just to say that ionic compounds come together because of positive and negative charges, cations and anions, and they do so to be more stable. From there, we'll get better and better. Take care, science fam.